Mr. Andrenik Arakelov, can you make video with template class using double pointer? I guess he means double pointer as pointer to something. Pointer is unwieldy. Pointer is hard to understand. Pointer is hard to use. So C++ committee created reference. However, pointer plays very important role in C++ programming, so I will explain it in detail. Let's get started. Hi everyone, my name is Thomas Kim. Today is April 11th, 2019. This is first episode about pointer, reference, and constant. First, a pointer is an object. In C++, any entity that has its own memory is an object. int, ptr is a pointer that points to an object of type int. ptr itself is an object that has its own memory. int a, an instance or object of type int. int alias a, alias is an lvalue reference. Non-constant lvalue reference is an alias. Alias does not have its own memory. That does not mean lvalue reference is not an object. Constant int ref to literal 5 ref to literal is an object. That means constant lvalue reference initialized with a literal is an object. So ref to literal is an object of its own memory. Constant int ref to lvalue, for example a, ref to lvalue is an alias. It does not have its own memory. Rvalue reference is not an alias. Rvalue reference has its own memory. int ref rvalue 5 ref rvalue is not an alias and has its own memory. Why C++ becomes such complicated? Why? Because there is dark history. C++ evolved from C. C does not have a reference. The biggest problem associated with a pointer is an initialized pointer. To overcome this issue, C++ originally introduced lvalue reference. When C++ introduced reference for the first time, they called it just reference. So reference was introduced to C++ to solve the problem of an initialized pointer. That being said, reference is destined to be initialized from the start. So we always have to initialize a reference, be it lvalue reference or Rvalue reference. When C++ introduced reference for the first time, the C++ community had thought it could resolve the problem of the pointers, but the history proved that the nightmare of uninitialized pointers recurred with C++ 98 standard. Start File Explorer, make a working folder. I will make pointer reference constant. Double click this folder and copy the folder path. Right click your command prompt, right click properties, paste the folder path, click OK. Start Visual Studio Code. File, open folder, paste the folder path, enter, select folder. Click this button, origin of reference, CPP. Include IO stream, include C Studio, void change me int pointer ptr int main int a 5 change me a. The ampersand in front of an object is address of operator. Now in this function, ptr plus 1 modify the value the pointer ptr points to. std cout before a std and l after a. Now let's compile. Start your command prompt. dir clang ++ origin of reference cpp. Hit enter. So AEXE is created. A before modify A is 5. Before modify, before we call this change me function, A is 5. After modify, after calling this function, in this function we increase 1. Then the value of A is updated to 6. This is C programming method to change parameter. function call parameter or argument. In C language, they use the pointer. What is the problem in this code? The problem in this function is that if ptr points to invalid address or is not initialized, your program is highly likely to crash. Let's try this program once again. Change me null, not null. Change me int pointer. This is cast 1 2 3. We have to call the interpret cast. I will say interpret cast. We are passing arbitrary address and call this function cout. Am I still okay? std and there. Now let's build and run this program. The program crashed. This message was not displayed. Now let's try with GNU compiler. Also this program crashed. Now with the Microsoft compiler, cl ehsc dir origin of reference. It crashed again. This is the biggest problem of pointer. Or in some case, int ptr, it is garbage address. Change me ptr. I will disable these two parts. An initialized pointer. I will copy this. Now let's try this code. An initialized pointer. Now let's try this code. Microsoft compiler. It gives warning. Now let's run it anyway. Crash it. This message is not displayed. With the GNU compiler, it gives no warning. exe is created. It crashed. With the clang, no warning. This message is displayed somehow, but still it's not correct way to program. The problem is here, initialized pointer. To solve this problem, to solve an initialized pointer problem, C++ introduced lvalue reference or reference to solve the problem of the uninitialized pointer. C++ introduced reference. Now we can modify like this. Change me ref int r1. Now we can call this function. I will disable this part. Change me ref a. Now let's build and run. A. Now it is changed through pointer. Changed through pointer once. Then it is changed once again through this function call. This is reference. Reference was originally introduced to solve the problem of an initialized pointer because reference should always be initialized. Say int r a. R is a reference. It should always be initialized. So change me ref r. We call this function again. Now let's build once again. So it works perfectly because reference should always be initialized. Reference should always be initialized. But this caused another problem. So C++ introduced reference. C++ introduced reference to solve the problem of an initialized pointer, but it caused another problem like this. Now we are passing this change me reference function like this. Change me ref 5. We are calling the function that takes a reference by passing a literal value. It does not compile because 5 is literal. It does not have memory. It cannot resolve because reference is an alias that references to an object that has memory. But in this case, the value 5, literal 5, does not have memory yet. Okay? So it does not work. No, it does not work. To solve this new issue, a smart C++ architect had a good idea to recycle keyword constant. Let's think about pointer to a constant object. Void take a pointer to constant like this. Constant int cptr. In this case, cptr points to constant. This code does not work because cptr is a pointer that points to a constant int. So the value of constant int or cptr should not be modifiable. So it does not work, but we can display std cout cptr. Though we cannot change a pointer that points to a constant object, the contents of the value we can read. I will disable this. A smart C++ architect came up with a brilliant idea to recycle the keyword constant by introducing constant reference. Void take a constant ref like this. Constant int cr std cout cr cr std and there cr1 does not work. So now we can take this function. We understand what is constant integer reference, constant reference. We can call it like this. 5. I will disable it. If we try this function, it should work. Now it works. Wait, there is one more issue. Since reference means a reference to an object that has memory, memory for this literal pipe should be created. Memory for this pipe should be created somewhere. Where the memory for pipe is created. The question is where is the memory created for literal constant reference? I don't know. Answer: I don't know, but we can test to find out like this. So int n printf the address of n %p address of n. I will copy this part, cut, paste here. I can declare another one. The address of m. M like this. Now we display here the address of CR like this. Printf the address of CR %p n CR. Okay. If we run it, we can test where this CR is created, like this. We will start with the Microsoft compiler first. This is Microsoft compiler. M. Please note that this is N, and here the address ends 54, and M is here. The address ends 5C. 545C. 5C is greater number. So in case of MSVC, the stack grows from low address to high address. From low to high. In case of G++, now let's try with GNU G++. This is G++. Please note that we have to give O 0 option. This means an optimization. No optimization. We have to give this option. Hit enter. G. This is 0C, 08. 0C is greater number. In case of G++, the stack grows from high to low address. In case of Clang++, the stack grows from, let's test. This is Clang. We also should give minus or 0 option. Clang. This is 0C is high address, 04 is low address. From high to low. From high to low. This is for x86 64 Windows 64-bit architecture. Okay, now we compute the difference of address auto diff like this. M, address of M minus address of N. The difference of addresses. If diff less than 0, then diff times -1. Make positive. Then we display the address std cout difference diff std and there. Now let's try with Microsoft first. In case of Microsoft, wow, the difference is 1. The difference between N and M is 1. What does this 1 mean? This is not 1 byte. This is not 1 byte. In case of MSVC, diff is 1. Not 1 byte, but 1 int. Okay? Now let's try with GNU, GCC. In case of GCC, the difference is 1. In case of G++, diff is 1. 1 instance of int. In case of Clang, now we test with Clang. See? Wow, the difference is 2. In case of Clang++, diff is 2. 2 instances of ints. This means from N and M, there is only not 1 byte, only 1 int. There cannot exist actually 1. Okay, because the difference is 1 int. From N, M, there is, if it does not exist, then it becomes 1. So this CR, this 5 is not in this stack. In case of GNU G++, memory for 5 is not in this stack. I say memory. Here in case of Clang, 2 means there is one other element. Between n and m there is something else, another int. Memory for 5 is between n and m. Okay? So this result gives us the following conclusion. In case of Microsoft compiler, the memory for 5 is not allocated between n and m, but allocated in this stack, in this function stack. And in case of Clang, the memory for 5 is allocated between n and m. Okay, n and m. That's why there is 2 ints. 2 ints. The difference is 2 ints between n and m. So when I started, I said the question is where the memory created for literal constant reference. The answer was I don't know, because it is implementation defined. Each compiler can give different result. Now let's disable this function call. I disabled, and let's test with Clang once again. Clang gives difference 1. Now let's enable it. Test Clang once again. Now the difference is 2. From this experiment, in case of Clang, when the argument is constant reference, lvalue reference, the caller, this is the caller. The caller should allocate the memory for constant reference. In case of Microsoft and GNU G++, let's test with GNU G++. The difference is 1 when it is enabled. Let's disable it. The difference is still 1. So the memory for 5 is not allocated in call stack, this caller's function stack. Through this experiment, you can find out any information about your compiler. To recap, the C++ standard does not stipulate how to implement. It only specifies the input and output. Originally, the reference in C++ was introduced to solve the problem of an initialized pointer. Later, constant reference is added to C++ to handle literal variable. This constant reference caused another hard to solve problem, optimization, by recycling temporary Rvalue. The C++ committee took 13 years to implement Rvalue reference. In future episode, we will talk more about pointer, reference, and constant. Please subscribe to my YouTube channel. Thank you for watching.